Ready to dive deep? We're tackling machine learning hyperparameters today,
Ooh, hyperparameters, nice.
specifically for linear regression. You know those settings you tweak on apps to get them just right? This is kind of like that, but instead of apps, we're talking about those powerful algorithms.
Yeah, those algorithms. And it's
How do you do
funny, we get so focused on the data itself, we forget about those control knobs, those
like
hyperparameters.
assuming every oven bakes the same.
Exactly.
You and I both know
What?
a cake can go very wrong if you ignore the temperature.
Oh, tell me about it.
Okay, so love the analogy,
Yeah.
but let's stick with the algorithms for now. Where do we even start with hyperparameters?
Let's kick things off with learning rate. So when we train a model, right, it has to adjust its internal settings, its weights and bias based on the data it sees. The learning rate tells it how big those adjustments should be with each step.
So is it like finding the right pace for learning?
Yeah. Yeah, like
Too slow and you're not getting anywhere, too fast and you miss important stuff?
you got it. A good learning rate, it helps the model make quick progress at first, and then it settles into those fine-tuned adjustments, as it gets closer to the best solution.
I see.
And your source material, it actually has a good visual of this. In Figure 21, you can practically see the model hitting its stride.
Ah, okay. And I'm guessing figures 22, 23, and 24 show what happens when it goes wrong.
Bingo. If the learning rate is too small, the model, it just crawls along. Too large, and it's all over the place, like missing opportunities left and right.
So no magic number then. Just got to find that sweet spot.
Exactly. Each data set, each problem, they all have their own perfect learning rate.
Okay, makes sense. Like adjusting the recipe based on your oven, right?
Right.
Now, what about batch size? I've heard that term, but how does it fit in?
Batch size, that comes into play when we have these massive data sets, which is like all the time in machine learning.
Right. Yeah.
Imagine trying to analyze like 1,000,000 data points one by one.
Oof, that's a lot.
Yeah, that's where batching comes in.
It's like trying to eat an elephant in one bite.
Exactly, you got to break it down.
Oh.
So we could analyze the entire data set at once. That's called full batch. Super accurate, but can be slow, especially with those million data point elephants.
So what are the other options? Speed eating the data.
Kinda. There's this thing called stochastic gradient descent, SGD.
Okay.
It analyzes each data point individually, updates the model on the fly.
So it's fast.
Fast, but can be all over the place. Like that one friend who makes snap judgments, without the full picture.
I know the type.
Right.
So I'm guessing there's a middle ground, something more balanced.
You know it. Mini batch SGD. Splits the difference. We analyze smaller groups of data. Not the whole elephant, not a single bite, but a good chunk.
So it's like testing different driving routes, but in smaller groups. You get a feel for things faster, but with less risk than just picking a random direction.
And you're getting it. And actually, if you look at figures 25 and 26 in your research,
Okay.
you can see this difference. SGD in figure 25, it creates a noisy graph, lots of ups and downs, while mini batch in 26, it's smoother, shows a more stable learning process.
This is making me rethink how I approach like all problem solving, not just machine learning. But we've covered learning rate, batch size. What's next on this hyperparameter tour? All right, so learning rate, batch size. We got a handle on those. But I feel like these hyperparameters are like ingredients in a recipe.
Yeah.
It's how you combine them that matters.
Oh, absolutely. It's not enough to just tweet each one separately.
Right.
It's about how they work together.
Gotcha.
So let's say you have a small learning rate, like that cautious driver,
Okay.
taking tiny steps down the mountain. Now pair that with a big batch size, where the model's processing a ton of data before adjusting.
Sounds like they might be working against each other.
Right.
Like taking forever to go down the mountain because you're averaging too much at once.
Exactly. You might need a larger learning rate in that case. Since you're looking at so many data points, you can afford to be bolder with each step.
I see.
And the opposite is true too. Small batch size, more frequent updates, you might want a smaller learning rate to avoid those wild swings.
A balancing act. So where do epochs fit into all of this?
Epochs. This is where the art of machine learning really comes in.
Ooh, okay.
More epochs, usually it means a better trained model,
Makes sense.
but too many, and you risk something called overfitting.
Overfitting, huh? What's that?
So imagine your model is like a student acing those practice questions after seeing them 1,000 times.
Right.
But then new data comes along, the real test, and they totally bomb it.
Because they just memorized, didn't actually learn.
Exactly. The model's gotten too used to the training data, picked up on all its little quirks, even the noise.
So it's like over-practicing those test questions. You're not getting smarter, just good at memorizing.
Exactly.
How do you even know when to stop? How do you prevent this overfitting?
That's the million-dollar question. Often, it involves looking at the model's performance on data it hasn't seen before, a validation set.
Oh, so like a separate test.
Yeah, like having a coach observe the training. Who can spot those bad habits?
Having that outside perspective so important. This all seems pretty complicated, though. For someone just starting out, this hyperparameter stuff could feel overwhelming.
Yeah.
What advice would you give to our listeners who might be feeling a little lost?
First thing, remember, it's all about experimenting. No magic formula. The perfect settings depend on the data, the algorithm, even your computer.
So embrace the experimentation, the trial and error.
Exactly. It's a journey. Start with a reasonable baseline, then tweak things, see what happens.
Like you said earlier, it's an art.
Right.
Speaking of unexpected things, you mentioned that even the noise we saw in those SGD graphs could be a good thing.
Ah, yes.
Now that I got to hear more about.
It's funny, right? Because usually we think of noise as bad.
Right.
But you see, in machine learning, we often have these things called local minima. Local minima.
We're not talking about like literal noise, right? Static on a phone line or something.
Then we're not quite. It's more about those random-looking jumps and dips in the learning process,
Right.
especially with something like SGD. You'd think we want a smooth, straight line to the best solution.
Makes sense.
But here's the thing. In machine learning, we often run into these things called local minima. Imagine, like, trying to find the lowest point in a valley.
Okay, I'm picturing it.
If you always go straight downhill, you might get stuck in a small ditch, right? Thinking you found the lowest point.
But there could be a much deeper valley just over the next hill.
Exactly. That's where a little randomness can actually help. Those jumps and dips from SGD. That's the model exploring, taking risks to see if there's a better solution out there.
So like adding a bit of calculated risk-taking.
Yeah, exactly. And it's not just SGD. There are techniques like adding noise to the data on purpose or dropout regularization, all based on this idea of using randomness to help the model generalize better.
To avoid those ditches,
Yeah.
basically.
Yeah, it's about finding that balance between like optimizing and exploring. You want the best solution, but you also need flexibility to adapt.
So it all comes back to that art of machine learning you mentioned.
It does. It's not just plugging in numbers. It's about knowing when to trust the process, when to shake things up.
Like being a coach.
Right.
Not just saying run faster,
Yeah.
but knowing when to push, when to rest.
Exactly. And that's what makes it so exciting. It's this dance between data, algorithms, and human intuition.
Well said. So as we wrap up today, I think the big takeaway is that hyperparameters, learning rate, batch size, epochs, they're not just settings.
Right.
They're tools.
Yeah.
Tools we use to shape how a model learns.
It's guide its journey. Yeah.
And as our listeners continue their own journeys into machine learning, don't be afraid to experiment, challenge those assumptions.
And maybe even embrace a little randomness along the way.
Love it. That's all the time we have for today's deep dive. We hope you learned a lot about the power of hyperparameters.
And the art of machine learning.
Until next time, keep those algorithms humming.